So let's get started. Thank you for joining today's webinar hosted by Landing AI and Capgemini. The title is Accelerate AI Deployment with Domain-Specific Large Vision Model in Energy and Utility. We will be recording this session and sharing with you after the webinar. So please utilize the Q&A feature on Zoom for any question during the presentation. We will address them following the presentation. With that, I will hand the mic over to Carl.
Thank you, Grace. Good morning, good afternoon, good evening, depending on where you're joining us from. My name's Carl Lewis, Senior Director of Partnerships at Landing AI. Delighted to be joined by Marcos Fernandez. Marcos is Director of Digital Engineering and Software at Capgemini. Landing AI has been working with Capgemini now for around 4 years. In that time, we have helped many companies innovate, reinvent, and transform their operations. So really looking forward to sharing details of some of these successes with everyone. I trust you'll find this time together enjoyable, insightful, and valuable. I'm sure everyone will have many questions to ask. So please share your comments, questions, perspectives in the chat throughout the webinar. Don't feel that you have to wait till the end. Please enter them in the chat and Grace will do her best to answer them. If we have any unanswered questions, we'll answer them at the end and take additional questions if we have time. So let's take a look at the agenda today. So Marcos is going to kick off the session. Marcos is going to talk about how Capgemini helps customers continually innovate. He'll also be discussing challenges to overcome when implementing computer vision solutions, sharing some examples of key results achieved and the value he has built for clients. Also, he'll be talking about typical steps to follow when applying a solution. Then we'll be transitioning to myself and I'll give an introduction to Landing AI. And also some exciting work that we've been doing around large vision models and how they can help accelerate time to value and also decrease project complexity, especially in energy and utilities. This will be followed by a demo. So I'll be dipping everyone's proverbial toe into Landing Lens, which is our powerful computer vision platform. And then as I said, we'll transition to a few user stories. So we have some customer testimonials and will be followed by Q&A. So as I said, if you have any comments, perspectives, questions, please feel free to enter them in the chat and we'll do our best to answer them throughout the webinar. With that said, Marcos, it's your turn to take the mic and take it away.
Great. So first of all, I would like to say thank you and we really appreciate to have this opportunity for inviting us to this webinar. It's been great working side by side with Landing AI for over, I would say that over 4 or 5 years, as Carl mentioned before, for the last 4 or 5 years, we've been engaged in some really interesting and really attractive, I would say, appealing projects in which we've been leveraging those models created or trained with Landing Lens. And it's been great working side by side with them. So, who's Capgemini? Why we are here? So I would say that Capgemini, it's a really large company. There are different teams doing different sort of works for different clients, top clients worldwide. But one of our main, and actually say the area in which the field in which I work for, we are involved in intelligent industry. We have really strong solutions and projects with top clients in the field of intelligent manufacturing, smart assets, intelligent assets, intelligent infrastructure. And we are always trying to find new approaches, trying to find new technologies that might help our clients in solving tough problems and get the most of that technology. So that is why we start working with Landing AI. We knew that AI is going to be with us for many years. It's the future, and we needed to accelerate the application of AI. We agree that now the opportunity in AI is for us at companies like us is in the application of AI, in trying to close the gap between the needs of our clients and the AI, how to apply AI to fix those or solve those problems they have. And we started working with Landing AI because they can provide us the foundational models in order to apply AI to tough problems or tough and solve issues in our clients. For that, actually, if you can move to next slide, please, Grace or Tar. In order to identify innovators such as Landing AI, we have our area dedicated to this. It's part of the innovation team at Capgemini. We are always trying to find those new technologies, new approaches. We dedicate time, and we dedicate time also to the go-to-market with our collaborators. So now, why we are here? So basically, one of the applications of AI and one of the problems that we are trying to fix now with our clients is in the field of infrastructure, and to be more specific, in the field of grid management or grid management improvement. So there's an opportunity and there's a challenge to modernize the grid, the electricity grid, and also it is involved. Sustainability is basically involved in that challenge. Can you move to next slide? And of course, AI has much to say when it comes to that challenge of modernizing the grid. So basically, what we do feel, and there's an analysis and report by FEDA about the modernization of the distribution networks in Spain, and there's another one similar for the rest of Europe. And basically, what this analysis says is that there's a major problem in terms of degradation of the grid, in terms of obsolescence of equipment. It is coming up. And also, there are challenges around the integration of self-consumption, integration of renewables, virtual communities, virtual plants. So there's a challenge there. There's a new approaches needed by how the grid is managed, how the grid is engineered, and how the grid is maintained. Also, the electric vehicle is going to be a challenge. And AI has much to say. The thing is that it is estimated by this study that digitalizing maintenance of the grid is going to bring something like 43 million euros in terms of benefits, savings for the grid. And needless to say that not only savings, but I'm quite sure that there will be many other benefits rather than just savings by integrating AI and digitalization in the maintenance of the grid. So innovation in automation of maintenance, by means of digitalization and AI is something key in the future. There are typical use that we are now, as you will see later, putting in practice, which is the combination of AI plus drones and cameras, thermographic or visual cameras. And the benefits you will see later in next slides, but the benefits are estimated to be in 30 to 40% of the savings of the current costs for that maintenance task. Okay, but so far so good. That's the scenario, and that's those are the potential benefits. But now, how to reap that fruit? How to get those benefits? And if you can go to next slide, please. Yeah. So for sure, AI is going to be key. It's there's potential behind, but for companies like us, the challenge of AI is how to go live with AI, how to make AI something we can deploy that can benefit all of us in terms of benefits for the clients, benefits for end customers, but also we need to be successful financially speaking, right? Financial success for all of us, and that's the main challenge. That's why Landing AI came and help us. So if you take models, if you take AI existing now, most of the times it's been models created by universities or you start from scratch, and performance and time to train those models is something that can be a challenge. It's tough. So we need to accelerate that. And also the typical situation we find when we are using AI, we are using models, is that images are not that good. Quality is not that good. Distance to the object of interest is very far, basically. We typically lack of large data sets. So that's a challenge also for training models and for training AI. And the thing is that there are many problems when we try to collect those images. So the less images we use and the best that the foundational models are is best for us in terms of making sure that we meet the deadlines of our projects and also the cost target of our projects. And that's the main our main that's our main goal when trying to fix these problems of application of AI-based computer vision to our clients, right? Can you please go to next slide? So what we do is that so there are different types of problems we can help by means of address by means of application of AI based computer vision. Now we have the right tools and the right AI to address those needs of our clients, and we have the foundational models. So the key part of our collaboration with clients for basically visual inspections of the assets is that we need to provide the models. But once we provide those models and those models are trained and running, you only have models, so you need more. You need to integrate those models into a bigger solution. You need to do something with the results of those models, with the inferences of those models. And that's why we created a platform, an application platform, in order to integrate, deploy those models, and be able to perform end-to-end inspections of grid assets for our clients, leveraging the models. And the thing is that with that application platform, what we've created is an automation platform that is able to take pictures of assets, electricity assets, from different sources, either drones, pictures taken by cameras, or pictures taken by helicopters. We take those pictures, we provide those pictures to our platform, and our platform is able to analyze pictures and identify a set of anomalies, defects, typical defects in those assets in the grid, in order to provide a report and warnings about any defect or anomaly detected. We started doing that for basically power towers and cables, wires. But afterwards, we extended to other assets in substations. And now we are also extending that to personal protection equipment and other types of different visual inspections that need to be done in the field of grid maintenance, right? Grid inspection, grid maintenance. And the thing is that we are now involved in a major new release for our automation platform, which is that it is not only going to analyze pictures, it is also going to locate or geolocate those pictures, and together with a geopositioning database, is going to tell which asset has an anomaly and compared to past inspections, and then get conclusions about how the grid is integrating, or what are the main issues of the grid. That is a major release for end October, beginning of November. Can you go to next slide, please? So basically, Antal will show how we do that. So basically, for us, the first step in order to implement our visual inspection solution for the grid is to select the anomalies our clients want to detect. As we already train models for those detections of anomalies, we most probably are able to deploy the solution and start detecting anomalies in assets of our clients from day one. But most probably, and it depends on the country, depends on regulation of each country, how the grid looks like in every country. Most probably, you will need to perform some refinement, fine-tuning of the models. That's what we do in step A. And once we fine-tune those models, we deploy in our platform, and that's the step B. And the thing is that maybe our clients want a different type of report, or they prefer a different look and feel of the application, so we can customize our visual inspection automation platform based on the requirements, or specific requirements of our clients. But this is not starting from scratch. It is already implemented. We just need to customize the platform. Can you please go to next slide? Which is what we do in step B. This is just a picture of what we do. So, as I mentioned before, we started with inspection of wires and power towers, but we've been lately focused on other issues. Hotspots in facilities, corrosion, vegetation too close, but also we are starting working with other types of mechanical anomalies in infrastructure, and even different issues in terms of compliance of the infrastructure. So the potential is huge. There are many other use cases, many other problems, and our vision for this is that we are not treating each use case or each problem in a separate way. What we think is that our automation platform on top of landing AI is going to be a platform cutting across different areas of the organization of the DSO, electricity distribution company. able to accommodate different AI's models in order to perform different types of visual inspections and providing end results in the form of reports or in the form of messages, so to speak, integrated with other solutions, messages to other solutions, other IT systems in the organization in order to suggest any action because of that anomaly. Good. Can you? Well, just to say that this is based on our experience, lessons learned. It is not important only the technology here. Technology is a key component for sure, but what we see is that for years, most of our clients in the electricity industry have been working in a certain way. They've been running their processes in a certain way. When you integrate, when you bring AI, you need to think different. You need to see that AI has its own way and its own potential and requirements in order to get the most. And that means that you also need to think in terms of change management and how to innovate in your processes. Because if you keep your processes like you've been running your processes, inspection processes for years, you will get benefits, but most probably you will not get all the benefits you can obtain if you change your processes or you change the skills, you upskill your team, right? Can you go to next slide? And basically, this is just for introduction. It is key to have a landing AI on board, landing links to be more specific, in order to support our platform for visual inspection. Great.
Thank you, Marco. Some great insights there. So I'm gonna talk a little bit about landing AI, but just before I do that, just the introduction of myself. So I'm responsible for partnerships at Landing. My background is in engineering. I did my first computer vision project as an intern at a university in the early 90s, and done many hundreds of projects. And the common theme is always we gotta best understand the application, and best understand the subjectivity in the application. That requires a lot of data. And during those many years of doing different computer vision projects, that took time to understand that subjectivity in application. And so now in 2024, being able to come from that perspective of projects generally taking months to deploy, now taking a few days, a few weeks to go from initial proof of concept to deployment. So really, the partnership with Capgemini is to help clients identify problems, but with the combination of Capgemini and Landing, we're able to accelerate that time to value. So projects don't take months, don't get stuck in POC stage for months on end. We're able to go through that process in a few weeks, like I said. So just to give a little bit of an intro to Landing AI for those who are not aware, the company was founded in 2017 by Andrew Ng, a prominent person who is well known in the space, is a thought leader in AI and computer science. And he wanted to build a company that gave accessibility to everyone. So anyone irrespective of background could build an AI model quickly and easily. And so we have a platform called Landing Lens that I'll talk to, and it's applied in different types of industries. And we also have large vision models, and I'll talk about that as well. But some of the challenges around deploying projects, especially a computer vision project, it's broken up into three buckets. So the first goal is really to take control of the data, getting access to the image data that may be available. It may be that there's an existing image set, many hundreds of thousands, potentially millions of images, and being able to make sense of it, being able to add metadata to it. So you understand what the different defect classes could be, and we have some techniques, label books, and agreement-based labeling to be able to do that. And then the second is model training. So once that data is labeled correctly, then it's all about training models, comparing model performance, understanding how they perform over time, and that's built into the platform. And then the last is how to deploy that model into production. And there are different ways to do that. One could be using the cloud to deploy on a cloud endpoint, or it could even be on an edge device let's say, in a drone, using Marcus's example, using Landing Edge, which is the name of our Edge app, or you could even do it in a Docker container on an edge device or in a server somewhere. So really, those three buckets are the main components to build the computer vision project. And we have our platform Landing Lens to enable users to do that quickly and efficiently. Next slide. So a little intro into LVMs. So just like LLMs that are really revolutionizing text, we're really spearheading LVMs. So a domain-specific LVM gives a user the ability to take existing images in a specific domain. So let's say you have a surveying helicopter that's out surveying infrastructure, and that helicopter could be taking millions of images. And those images may vary quite a bit depending on the day, the location, and using those millions of images, we can train a domain-specific LVM, which means that those images do not require to be labeled. And we build a foundation model, which means that the foundation model is able to look at the unique features in those images, all the individual features and how they relate to each other. And then once that foundation model has been trained, we can then add specific tasks. So we can add a segmentation tool, we can draw masks on an object. Maybe we're interested in differentiating between different characteristics on a thermal image, and we draw a specific mask on a thermal image. But we're just labeling a few images of the defects that we're interested in detecting. Or we could be using an object detection model to, let's say, look for an insulator in infrastructure, or we could just be classifying objects good and bad. So the goal with the LVM is to take that big data set, remove the need to label those images individually, train a foundation model, and then we can fine tune it based on a few labels on what we're interested in detecting, which means that we get a really high-performing model compared to a traditional method of having to label millions and millions of images. So some really exciting developments from Landing AI, and we're bringing that to the market with Marcus and Capgemini. Next slide. So here's a great example of some of the technology we have to accelerate some of those applications. We have a tool called visual prompting, which is our version of single shot learning, which means that we can take a few images and we can actually isolate the objects that we're interested in detecting by just drawing on the image. So there you can see on the image on the right-hand side, we've drawn two classes, the background and the foreground, and the model will actually predict and fine-tune the model based on what we have isolated. So the tools are available in there for customers to really build models really quickly with using a lot of data. Next slide. Okay, so I think that's my point to share my screen. Okay. So let's go into a demo. You should be able to see my screen.
Yes.
Marcus, do you see my screen? Okay, perfect. All right, so little intro into.
I can, yes. Should I start?
Perfect.
Should I start with my demo and then maybe with yours?
Oh, sorry, I got the order wrong. Sorry about that. Let's
thanks.
Go ahead.
I should now share my screen. Let me try. I'm not sure if you can see my screen now?
Yes.
Yes.
Okay. Where shall you? Let's see if I can make it bigger. No. Good. So just to continue with the example. So what we typically do is we created this platform, this automation, visual inspection automation platform, which runs different functionalities, but it is running on top of landing links, which provides those models. So what we basically do in this platform, this is an example, an instance of our platform for a specific problem, one demo we have. So basically, what I would like to show you is how we are able to here create an inspection and get a report, an inspection report of several assets in electricity. So basically, for this demo, what we have is 7 images, up to 7 images. These are actually real images taken by helicopters. You can see here how far they are and the typical quality. These are 20 megabytes, I think it's 5 or 20 megabytes images, 5,000 pixels by 5,000, more or less. So this is a typical situation. Our clients want to perform visual inspection of these assets, automated. In this case, what they want to identify is if there's vegetation here in this part of the power tower, which is something that might present a risk, might pose a risk. So basically, here you can see a typical situation. This is what I mentioned before. If you are building a model for research, maybe this is not the typical picture you're going to come across, but these are indeed the pictures that helicopters take. The quality is not that good, but our models need to identify if there's vegetation here in this area of the power tower. So we have 7 images. For this demo, we put those images here in this folder, which is the one that our solution will read. But if there are many other ways of providing those pictures. You can provide them directly by means of an API. So you come here, you basically, you can write any name for the line. You can check the inspection we want to perform. In this case, is basically vegetation. We are going to provide, I hope not to be wrong with the name of the folder. I think it's that one. You provide the name of the folder where those images are, the type of inspection, and you run this inspection. Typically, we are analyzing sometimes thousands, hundreds of thousands of images. We need to run that asynchronously. So you can see the report as images are being analyzed. You can see here the image and the result, that image. Here there's no vegetation. Here, let's see another one. So for example, this one, according to the rules and the train we perform, these images, yes, there's some vegetation here, which is a risk for the power tower. So basically, this is an example of what we are able to do. This is the part of the inference and creating a report with the anomalies detected. But before getting to this point of performing inference, there are other steps customizing this platform for a specific inspection you want to perform, or the specific report you prefer to get. And much before that, fine-tuning, or maybe if the use case is brand new, train the models. And that's what what Karen is going to present now, right? Yeah.
And Marco, you may stop sharing your screen.
I think it's here. Here.
You're on mute, Marco.
Okay, thanks, Marcos. All right, so let's take a look at Landing Lens. So as I mentioned before, Landing Lens is the name of our computer vision platform, and the goal with Landing Lens is to make prototyping and deployment of computer vision projects simple and really easy, and accelerate that time to value. So when you open Landing Lens, you'll see this main page, and I'll go through actually the same project that the Marcus highlighted there, and go through the steps to train your model. But before I do that, just give a little bit of a tour here. So this is the main landing page. This is where you would create your first project. On the landing page, there's a section with pre-built models where you can experiment a little bit. So for example, if I click on one of the pre-built projects here, I will see that it's going to show me all the training data that was used to create a model. And then I can actually run predictions real time using the images provided, and it will give me predictions. I can also use a webcam if I was interested in doing that. So there's a fun one here. So I could actually use my own webcam and use the deck of playing cards to test the model here if I so wished. But it's just really to give a fun introduction to the things that are possible. So if I look at the project page, I'll see a number of projects that have already been created. And here I'll see this blue box. I'll just click here. So this is where I get started with my project. So I have 4 project types I can use to build a project. Object detection, where I'm using bounding boxes to locate an object. Segmentation, where I'm actually drawing individual pixels, and it'll create a specific mask once it finds that defect in the field of view. Classification is where I'm classifying the images, and maybe I'm importing images already with labels, and I'm using those already classified images to classify new images as they're presented to the model. And then visual prompting, which I highlighted a little bit earlier, which is where I label a few images and I actually draw the specific details in the images I'm interested in detecting. So just going back to the context that we talked about, which was LVMs and landing lens. So I just want to draw a distinction between the two. So I mentioned LVM is technology that we're really spearheading, which means that you can build a foundation model using many images, and that will provide the basis for the model to learn from. So essentially it means that you'll be able to fine tune the model within landing lens using a few images that you label yourself. So if I use this as an example, okay, so this is an application. This is an application that Marcos was talking about. So let me go into a couple of these images. So here you see a power tower, and it's an object detection project. You can see this box here, which is the labeled image, right? We're just locating this power tower, and by type, by design, and this is actually the prediction that was made, the box in dashes. So as we're going through this project, you can see the different predictions on basically what the model found. So it could be that you're looking to detect vegetation. You could be looking to detect specific, elements of the weed. Maybe it's grown to a height that you want it to be detected. So in this case, this model detected weed at the base of the power tower. So on the right-hand side, what you'll see is the model performance. So you'll see two metrics here. You'll see precision and you'll see recall. So you'll see here precision is percentage of accurate predictions out of the total number of predictions. And then recall is a percentage of accurate predictions out of the total number of actual predictions. So the idea here is how precise was the model, and then how many times did the model recall correctly. So the idea with landing lens is that it gives you an ability to iterate. So you're not going to get perfect results right away, but it gives you the ability to iterate. It could be that you want to tune your model a little bit. Maybe you want to introduce additional images to get better results. So it's a great and easy way to do that. So once you have a model that you're happy with, then you're ready to deploy the model. So there are a few choices here. So you could create a cloud endpoint. So this is a specific cloud endpoint and a specific API key that is provided, and you can use that to connect from another REST API, or you could deploy to an edge device. You could use the Landing Edge app that Landing AI has, or you could deploy to a Docker container on an edge device, or it could even be a server. So I think that's it on the demo side. I'm going to stop sharing my screen here, and we'll go back to Marcos.
Let me know if you can hear.
Currently, we're leveraging the potential of AI combined with other technologies to address a diverse range of daily visual inspection challenges in different industries. Problems that were traditionally approached manually and involve recurring inspections. That's something that you have to have a look over and over again. This includes infrastructure inspection projects, for example, defect detections in production lines, and even analysis related to healthcare, like test tubes or racks, etc.
We are using computer vision to detect defects in our networks. As an electricity distribution company, we have to guarantee the good condition of the network from a supply point of view, but also from a security point of view. We carry out a visual inspection program that allows us to capture images of our assets, and we use AI for processing.
In our case, visual inspection of images conducted by a human is time-consuming and does not allow for a stable traceability of inspection quality, or maybe involves a significant increase in cost. However, AI is not a magical solution. It requires careful upfront planning for training and subsequent reliability analysis. This post-analysis must be periodically reviewed to ensure that the conditions for which we train the model have not changed. If they have changed, we need to assess whether an update to the model is necessary.
We see many advantages in using this technology, but for us, without a doubt, the most relevant are the accuracy achieved in the result compared to the one obtained with human review, and time savings compared to manual process. Using AI allows us to have a more precise knowledge of the status of assets in the shortest possible time. It also allows us to reduce human errors that identify problems that don't exist or ignore existing problems, which results in cost and time savings and an increased quality of supply.
Well, it's evident that research forms the foundation for the functionality of these projects, just as a human requires specialization to perform a task thoroughly. Adapting AI to address real-world problems is what truly has.
From my point of view, I believe that it is more efficient and effective to focus on use cases, since this allows us to identify the specific shortcomings of the technology in each case and avoids the dispersion that would prevent achieving short-term goals. I believe that this approach represents a sustainable evolution adapted to the real needs of the companies.
The automotive sector has always been an innovative agent, incorporating the latest technology in the search for efficiency and quality. In our continuous innovation projects to provide solutions to the sector, we have developed our Angelens visual inspection solution. Thanks to LandingAI's deep learning knowledge and our experience in vision system and IT/OT integration, we are able to offer a unique solution on the market, capable of integrating into current systems and scaling, becoming the software platform that can centralize current use cases and deploy new ones in different types of processes: welding, stamping, painting, assembly, storage, and materials, metal, plastic, foams, fabrics. Our commitment is to offer a robust platform that allows different use cases to be articulated, centralizing visual inspection operations, and thus generating efficiencies with which to achieve ROE.
So I think basically for wrapping up, we've been asked many times about the potential benefits, as we are not just an engineering company, we are a consulting company. So my colleagues in the consulting area usually are asked about the benefits. It's difficult to say, generally speaking, but if we go to specific cases, I see two different types of benefits. One type of benefit is in terms of if you go to this combination of solutions by Angelens and Capgemini and LandingAI, LandingAI, you are able to get better results. You need less time, as Carl mentioned, in order to train the models. You need less time to deploy them and start working with them, given that you have a platform in which those inferences can run and get results, get reports, get messages to other systems, to integrate with other systems. And that in the end, at the end of the day, is basically that you have less time to market your solution, of your AI solution, and higher accuracy for sure. And then there's a side effect of this, which is that and this is quite common when our clients see this, there are many ideas popping up. There are many other use cases they identify as potential use cases to deploy on this platform. And then it's not just benefits of our solution in terms of time to market and accuracy and performance, is also in terms of the impact for the business. And in terms of the impact for the business, typically, if you, I prefer to go to specific problems or situations that we address. And if you take that part of inspecting grid lines, our estimation, and that's the estimation elaborated by several partners that provide different parts of the solution, not just the AI and the automation platform, but also helicopters or drones or satellites. Our estimations is that savings can be around 30 to 40% of the current costs. And if you go to other type of inspections in substations, the potential is huge because basically it's doing nothing and expect not to have incidents versus being able to identify them in advance. So it's basically doing what was never done before in the inspection of substations. And that means higher availability of the grid.
All right. Thank you both. And with that, we will move to the Q&A sections. I see a lot of people ask the questions. Feel free to use Q&A chat function on Zoom. We will cover as time permit. So first question is from Edward. I'm curious about the order of magnitude. If you have millions of images taken that doesn't all require labeling, how many defects would a user typically label?
I can take that, Marcus. So
yeah.
So yeah, maybe I can answer it partially, and then maybe Marcus build on my answer. So I think it depends on the subjectivity of the application and the defect classes that you wish to identify. So as the subjectivity increases, then the model would need to better understand what you're mostly interested in. So, if you think about that, the more objective the application is, fewer number of labels are needed by the user. So it really depends on the use case. So as subjectivity goes up, the more detail is needed from a human on how a defect is represented. Marcus, anything to add there?
Well, we are getting, I would say, good results, really good results. With, for example, it depends on the problem you want to address. But for example, for insulators or for hot spots, no more than 1,000, maybe 2,000 images. We need to train the models. And so we need to label more or less half of the images have defects. So we need to label 500 or 1,000 images. It is time consuming for sure, but I wouldn't say that it is time consuming labeling the images. What is time consuming is curating the images, the image set, in order to have the right set to train your models and to get the best precision and record that Carl was showing before.
Yeah, and just expand on what you said. I think with LVMs particularly, um, so when the foundation model is trained, no labels are required, but fine tuning in landing lens, there would be very few images that would need to be labeled. So it really depends on the use case. I don't think there is a number. But if you think about landing lens for Marcus's example, needing 1,000, labels, then perhaps with the LVM, 300 are needed, right? So it really depends on the use case.
Thank you. Follow-up question is, how does Landing AI and Landing Lens or Capgemini address images of different resolution or quality? Can model in Landing Lens handle data set with different resolution images?
So the answer is yes. We do support high resolution images up to 31 megapixel. So answer is yes. It's still important to think about visible contrast in the image. So as long as there's visible contrast where you can see the contrast between the object and the background, that's really important to observe that in the image. But yeah, the answer is yes.
Thank you. Anything, Marco, you want to add?
No, I agree. So the thing is that it is not a matter of the quality that is supported by different types of quality or resolution that is supported by landing links. That's not an issue. The focus is how similar is that data set to the real situation you are going to face during inference, during the execution of your models. That's the focus. After that, different resolutions, different quality, that is not an issue for landing links for the platform.
Thank you. And next question is around the relationship between Landing AI and Capgemini. So let's say if someone has a problem detecting defects on PCB board, how the Capgemini and Landing AI work together to address the problem that he has. Could you give, maybe you already addressed the process, the collaboration, but if you want to add any additional here.
Marcus, do you want to take that?
Yeah. So the thing is that, I think, correct me if I'm wrong, Carl, but what we provide is the application of the models. We need the technology, the models, foundational models, and somebody else need to train and to deploy those models in a platform, providing an end-to-end solution. If you only have the models and landing links, you have the infrastructure, so to speak, to train the models, but then you need to run inferences, and you need to run inferences that need to be actionable by and provide an end-to-end solution to your clients. And that's what we do at Capgemini. We customize our platform in order to provide an end-to-end solution, and we instantiate, or we call those models trained by means of landing links.
Yeah, so just to add to that, I think Capgemini, as a partner, contextualizes the solution according to the problem that needs to be solved. So, if it is PCB inspection on the production line, there are many more elements than just model training. How does the solution get integrated into the production line? Integration with hardware, integration with edge devices, or integration with the cloud. How are all those elements going to come together? Rejection of PCBs, how is that handled? Rework, all those different things. So Capgemini really looks at the solution holistically and see how it can be integrated into a user's production line, using the PCB as an example.
In
Thank
terms
you.
of time, my experience in the last 4 years working together is that typically models AI takes 20% of our time, 25% maybe. The rest of the time, it's time dedicated to cameras, hardware. It's dedicated to integration with other systems, customization of our platform. Sometimes maybe we need to deploy a brand new platform in other manufacturing areas for manufacturing, for example, for other manufacturing applications. So that's my experience. 70%, 75% of the time dedicated to other tasks, 25 to AI. So it's when you face a problem in which AI can help, there are many other components, many other pieces of the solution you need to address, and that's why we are here.
Thank you. I know we are out of time here, so any question that we couldn't address in this call, we will follow up via email. And we also offer no-cost free consultation with the computer vision specialist. If you would like to schedule a call to address any use case that you worked on, feel free to schedule a time. I put in the chat as well. So with that, we will wrap up the session today. Thank you, both Carl and Marco, for awesome session today, and looking forward to see you next time. Thank you, everyone, for joining today's session.